Time travel. It's a concept that sparks our imagination, the ability to journey through time, to witness historical events, or to glimpse the future. It's a tantalizing idea, full of possibilities. Imagine standing alongside dinosaurs, witnessing the pyramids' construction, or traveling to distant galaxies. Time travel has captivated humanity for centuries. Stories of time travel appear in myths and legends across cultures. These tales often feature heroes journeying to mystical realms where time flows differently. The allure of time travel lies in its promise of exploration, adventure, and perhaps even the chance to alter destiny. But is time travel truly possible, or is it merely a product of our wildest imaginations? Science fiction has certainly explored time travel extensively, from H.G. Wells' The Time Machine to the countless films and TV shows that followed. These works of fiction often serve as thought experiments. They explore the potential consequences and paradoxes of manipulating time. While the idea of time travel may seem fantastical, it's a topic that has intrigued scientists and philosophers for generations. In the next section, we'll delve into the scientific theories that attempt to explain the possibilities and limitations of time travel. Let's explore the universe's grand stage and see where the cosmic play of time might take us. When we talk about time travel, we must turn to the language of physics, particularly Albert Einstein's theory of relativity. Einstein's theories revolutionized our understanding of space and time. They suggest that time is not absolute, but is relative to the observer's frame of reference. One of the intriguing implications of Einstein's theories is time dilation. Time dilation suggests that time can pass at different rates for observers who are moving relative to each other, or who are experiencing different gravitational fields. For example, time slows down at higher speeds. This means that an astronaut traveling at a significant fraction of the speed of light would age slower than someone on Earth. While time dilation is a real phenomenon, it doesn't quite give us a way to build a time machine. The time differences created by time dilation are relatively small, even at very high speeds. To travel through time in a meaningful way, we need to look beyond our current understanding of physics. Some physicists theorize about the existence of wormholes. Wormholes are hypothetical tunnels that connect different points in space-time. Theoretically, a wormhole could act as a shortcut, allowing travel between two distant points in space or even time. However, the existence of wormholes remains purely theoretical. There's no evidence to suggest that they exist, and even if they did, the technology required to manipulate them would be far beyond our current capabilities. Throughout history, humans have been fascinated by the concept of time. Many cultures have myths and legends about beings with the power to manipulate time or travel through it. In Hindu mythology, the deity Kala is often depicted as the personification of time, controlling the cycle of creation and destruction. Ancient Greek mythology tells of Kronos, the god of time, who devoured his children to prevent them from overthrowing him. Beyond mythology, the concept of time travel began to emerge in literature. Early science fiction writers like H.G. Wells explored the potential consequences of time travel, introducing themes that would later become staples of the genre, such as paradoxes and the butterfly effect. These stories often served as cautionary tales, highlighting the potential dangers of tampering with the natural order of time. Today, time travel is a common theme in movies, television shows, and books. From the classic Back to the Future franchise to the mind-bending complexities of Interstellar, these stories continue to captivate audiences. They allow us to explore the possibilities of time travel, wrestle with its ethical implications, and imagine what it would be like to hold the power to manipulate the fabric of time itself. The enduring fascination with time travel in popular culture speaks to our innate curiosity about the nature of time, our place within its grand scheme, and the tantalizing possibility of rewriting the past or glimpsing the future. While the idea of time travel is captivating, it also presents a host of mind-boggling paradoxes. These paradoxes arise from the potential for logical inconsistencies when considering the nature of cause and effect within the context of time travel. One of the most famous of these is the grandfather paradox. Imagine a scenario where a time traveler journeys to the past and accidentally kills their own grandfather before their parent was even born. This action seems to create an impossible situation. If the grandfather is dead, the time traveler's parent could not have been born, and therefore the time traveler themselves could not exist to travel back in time in the first place. The grandfather paradox highlights the potential for causal loops. A causal loop occurs when an event is both the cause and effect of another event, creating a closed loop where cause and effect become entangled. These paradoxical situations raise questions about the nature of free will within the context of time travel. If one could travel to the past, could they truly change it? Or are they destined to play out a predetermined role in the grand tapestry of space-time? While these paradoxes are intriguing to ponder, it's important to remember that they are theoretical exercises. They highlight the potential logical inconsistencies that arise when we try to reconcile our current understanding of physics with the hypothetical possibility of time travel. As we continue to unravel the mysteries of the universe, perhaps one day, the seemingly fantastical idea of time travel will transition from the realm of science fiction to scientific reality. Until then, it remains a captivating concept that fuels our imaginations and prompts us to contemplate our place within the grand symphony of time and space.